Scrambled from Joint Base Andrews near Washington Sunday, two F-16 fighter jets racing to intercept a private Cessna Citation jet.
Fighter jets have been evolving continuously over the years, and today, these machines boast remarkable capabilities that push the boundaries of aerial warfare. The U.S. has always been at the forefront of this development, constantly innovating new fighters and training their pilots to become even more skillful in the art of aerial combat. The latest fighter jet released by the U.S. has captured the attention of rival countries, leaving them on the edge of their seats. But why is this new fighter causing such a stir? And how does it challenge the technologies of these rival states? Join us as we explore the U.S.'s most advanced fighter jet in the world. The evolution of fighter jets. Fighter jets have come a long way since their early days, when they were equipped with basic features like propulsion, machine guns, and unguided rockets. Those early jets were revolutionary at the time, but they lacked the sophisticated self-protection measures we see today. Now, most modern fighter jets in service today are fourth generation or fourth and a half generation models. These jets have good maneuverability, the ability to lock onto targets below them, and reduced visibility on radar, but they are slowly becoming outdated. As technology advances, fifth generation jets are taking the stage. Fifth generation jets are the most advanced aircraft around, but they come with a hefty price tag. Currently, there are only a few models in operation worldwide. These jets offer exceptional capabilities that make them worth the investment. Russian engineers, for one, define a fifth-generation fighter jet as a state-of-the-art aircraft that excels in several key areas. These jets can achieve supersonic cruising speeds without needing an afterburner and possess advanced stealth technology to minimize detection by enemy radar. The jets are highly maneuverable for counter-air combat and feature advanced avionics systems capable of tracking up to 100 targets and engaging over 10 targets simultaneously. They can carry a variety of weapons in their internal bays, including an autocannon, and can take off and land on shorter runways. A notable example of Russian engineering in fifth-generation fighter jets is the Sukhoi 57, also known as the Su-57. This advanced aircraft was designed with the capability to operate from Russia's sole aircraft carrier, the Admiral Kuznetsov, which is expected to return to service after 2024. Russia's Su-57 Felon is known for its speed and ability to cruise at supersonic levels. It also features advanced infrared search and tracking, making it great at detecting and locating targets. It's heavily armed for close combat and carries an advanced onboard computer to help pilots navigate tricky situations. The Su-57 also boasts impressive features, such as an X-band onboard active array radar system with a detection range exceeding 400 kilometers. This radar can track up to 60 targets and engage up to 16 targets simultaneously using its internal weapon systems. The aircraft also includes an infrared search and tracking system, useful for identifying and tracking objects emitting infrared radiation. Additionally, the Su-57 features a GS-301 30mm cannon that is internally mounted and has a rate of fire of 1,500 rounds per minute. This weapon is designed for dogfights and engaging lightly armored targets. The cockpit is equipped with multiple layers of radio-absorbing materials for added protection, and automation assists the pilot with routine tasks, allowing them to focus on search and attack operations. The aircraft is equipped with a missile sensor to alert the pilot of incoming threats and features extensions to improve airflow during high angles of attack and low airspeeds. Leading-edge flaps, ailerons, and elevons contribute to lift, stability, and control during flight. The aircraft's thrust vectoring nozzles provide it with super maneuverability, a crucial advantage in aerial dogfights. How China developed its fifth-generation fighter. There's also China's J-20, also known as the Mighty Dragon. The story of the J-20, the fifth-generation Chinese fighter jet, goes back to the JXX program in the early 1990s. This ambitious program aimed to procure a next-generation fighter for China. At the time, China lacked the expertise, engines, and experience with stealth technology necessary for such an endeavor. Their background was primarily in copying Soviet aircraft during the Cold War, but they did have a vital asset: money. With the fall of the Soviet Union, China seized the opportunity to acquire top-tier Soviet technology from Russia and Ukraine during the 1990s and early 2000s. In 2009, however, a major data leak of F-35 documentation, orchestrated by Chinese hackers, provided China with valuable insights into American fighter jet technology. These resources helped shape the J-20, blending Eastern and Western experiences. The Chengdu Aircraft Corporation won the contract over Shenyang in 2008 and presented the first prototype of the J-20 in 2011. The initial response to the J-20 was skeptical. Many considered it just another Chinese attempt at copying existing technology, and its design seemed to borrow heavily from the F-22 and MiG-144, using mature stealth concepts from the F-22 and F-35. Additionally, it incorporated delta wings and a canard design, similar to the Rafale and Eurofighter. However, the J-20 is more than just a copy. It is the largest fifth-generation aircraft at 21.4 meters long, even bigger than the flanker jets, which are already substantial in size. Its canards complement its delta wing configuration, helping with flight stability since there are no horizontal stabilizers at the rear of the fuselage. The J-20 also uses stealth technology to stay under the radar and has potential as a bomber, electronic warfare carrier-based, or even unmanned aircraft. This adaptability makes the J-20 a formidable opponent. Development of fifth-generation fighters in the U.S. Now, in the United States, the F-22 Raptor is a force to be reckoned with. The F-22 Raptor is one of the most formidable air-to-air fighter jets in the world, boasting impressive speed, agility, and stealth technology. It can reach speeds of over 1,500 miles per hour and glide through the sky almost undetected, earning its title as the King of the Sky. The Raptor's stealth capability comes from its radar-absorbing paint, known as low observability, LO, which keeps it virtually invisible on enemy radar. By the time it's detected, it's often too late for adversaries. As an air dominance fighter, the F-22 was designed to outpace and outperform anything in the sky. It can fly at speeds exceeding twice the speed of sound and reach altitudes as high as 60,000 feet. The jet's maneuverability is top-notch, thanks to its two Pratt & Whitney F119 turbofan engines that produce 35,000 pounds of thrust each. This power allows the Raptor to maintain supercruise, meaning it can fly supersonic without using afterburners, which is a unique capability. The F-22's pilot can control the thrust's direction by roughly 20 degrees through thrust vectoring. This gives the jet the ability to perform incredible maneuvers that seem to defy physics, making it a challenging adversary in combat. In terms of weaponry, the F-22 carries a range of armaments, including 6 AIM-120 radar missiles and 2 Sidewinder heat-seeking missiles. It also features a 6-barrel Gatling gun capable of firing 6,000 rounds per minute, adding to its lethal firepower. Raytheon supplies the munitions and technology for the F-22, such as the AIM-9X air-to-air missile used to take down high-altitude objects, including a Chinese surveillance balloon. Raytheon is continuously innovating and enhancing its missile systems, such as the AIM-120D3 and C-8 variants, which offer longer ranges and more advanced capabilities. Raytheon also excels in air-to-ground weapons, with its Stormbreaker smart weapon capable of striking mobile targets up to 45 miles away, even in adverse weather conditions. This technology helps minimize air crews' exposure to danger. Another standout weapon from Raytheon is the Joint Strike Missile, a long-distance, highly maneuverable missile designed to take on heavily defended targets on land and sea. With its advanced technology and capabilities, the F-22 Raptor, paired with Raytheon's weaponry, remains at the forefront of modern aerial combat. This jet also has the ability to collect and share tactical data with other friendly aircraft, which enhances coordination during battles. The F-35, US's second fifth-generation fighter. The USA's F-35 is another top-notch fifth-generation jet. The F-35 Lightning II is a state-of-the-art strike fighter aircraft being produced in various versions for the United States Air Force, Marine Corps, and Navy. This aircraft is designed with a comprehensive approach to the modern battle space, offering flexibility and capability to the U.S. and its allies. The F-35 combines multiple capabilities, including electronic attack, stealth, and advanced avionics, which are essential for future mission success. General Mike Hostage, former commander of Air Combat Command in the U.S. Air Force, highlighted the significance of both stealth and advanced avionics for fifth-generation aircraft. It combines low observable stealth technology with internal weapon storage for a sleek profile. Its long-range radar and electronic warfare system allow for jamming enemy radar and disrupting attacks. The F-35's helmet display system gives pilots greater situational awareness. After Barack Obama was elected president in 2008, then Secretary of Defense Robert Gates decided to withdraw his support for the Air Force's F-22 Raptor procurement. This decision marked a major shift in strategy, as Gates believed that a large fleet of air superiority fighters was no longer central to U.S. strategy. This led to the focus on the F-35's Lightning II, placing a lot of pressure on the smaller aircraft to take on a larger role in air campaigns. The shift to the F-35 introduces technological, programmatic, operational, and strategic risks. Nevertheless, it was intended to serve as the foundation for the United States and its allies' air fleets, offering stealth capabilities and advanced technology. The original plan called for 750 F-22s and possibly up to 4,500 F-35s, including those for allied countries. The intention was to build these fleets rapidly through concurrent development. However, changes in defense budgets and strategies, as well as the reduced procurement of the F-22, resulted in an unexpected shift in the makeup of the air forces. The cost of purchasing the F-35, which was previously over $100 million, has decreased to under $80 million per aircraft. This price reduction makes the F-35 more affordable than a new F-16, which is a fourth-generation fighter. Still, there have been debates in Congress about the F-35 program, particularly among House Democrats, who recently considered the possibility of scrapping the concept altogether. While the program aimed to replace fourth-generation tactical aircraft with the F-35, the reduced number of F-22s and ongoing challenges with the F-35 program leave questions about the readiness and capabilities of the U.S. air fleet in a high-stakes conflict. Despite the uncertainties, there remains no clear alternative to the current approach. However, the Air Force has started exploring the idea of a sixth-generation fighter, the development of the U.S. Advanced Fighter Jet. The U.S. is preparing a next-generation fighter jet, known as Next Generation Air Dominance (NGAD), to ensure continued American air superiority for years to come. This new fighter is set to revolutionize aerospace technology and may outpace the already impressive F-22 Raptor. With an advanced avionics suite, the NGAD jet will have the ability to precisely target and strike areas across the globe. Its stealth capabilities will allow it to operate undetected, even in highly contested environments. The NGAD program is focused on developing a family of systems, including the sixth-generation fighter aircraft and unmanned aircraft. These will all work together seamlessly thanks to shared technology and systems, which could simplify maintenance and upgrades and offer a significant economy of scale. One of the key features of the NGAD fighter is its use of advanced active electronically scanned array (AESA) radars. These radars offer a high degree of sensor fusion, combining multiple functions such as sensing, electronic warfare, and communications into a single, multi-mode system. This integration creates a comprehensive tactical picture of the battle space, allowing the aircraft to operate more effectively and efficiently. The use of smart skins integrated into the aircraft's fuselage will enhance the AESA radar's capabilities. These smart skins offer spherical coverage, wideband capabilities, and the ability to detect multiple targets at once with high precision. They can also improve the aircraft's ability to engage in electronic warfare and counter-enemy stealth technologies. Another notable aspect of the NGAD fighter is its stealth technology, which goes beyond simply applying a special paint. The aircraft's design and technology work together to reduce its radar, infrared, and acoustic signatures, making it nearly invisible to enemy forces. This level of stealth is essential for the success of future missions and ensures the safety of pilots and crews. One of the standout features of the NGAD fighter is its emphasis on minimizing its radar cross-section. This is a measure of how much radar energy the fighter reflects back to the source. By reducing its visibility to radar, the NGAD fighter will be less likely to be detected by enemy forces. The fighter achieves this through smooth, angular surfaces that deflect radar waves away from the source rather than reflecting them. Additionally, the design includes no vertical stabilizers, which helps minimize reflective surfaces and sets it apart as the first fighter jet with such a design. The aircraft will also use radar-absorbent materials to scatter or absorb radar waves rather than reflecting them. This reduces the fighter's infrared signature and makes it harder for infrared sensors to detect the aircraft. The engines and exhausts are equipped with cooling systems to reduce heat emission, which further minimizes the infrared signature. Heat sinks and heat exchangers help dissipate heat throughout the aircraft or into the surrounding air. Another important aspect of the NGAD fighter is its low acoustic signature. In other words, the fighter must operate as quietly as possible to avoid detection. Noise-canceling technologies, as well as noise masking and reduction measures, ensure the fighter remains as silent as possible during operations. The NGAD program is also developing a new type of engine, known as an adaptive cycle engine. This engine can switch between high-speed and long-range modes, providing unmatched versatility. By toggling between speed and range, the adaptive cycle engine allows the fighter to adapt to various mission requirements efficiently. This technology could revolutionize airframe and engine integration, potentially transforming the way fighter jets are designed and operated. The Air Force plans to integrate the NGAD fighters with the F-35 Lightning IIs, creating a powerful combination of 5th and 6th generation aircraft. Each NGAD fighter will be paired with 2 unmanned loyal wingmen for missions, creating a comprehensive and effective combat team. The NGAD program has already invested billions of dollars into research and development, with plans to continue substantial investments in the coming years. The resulting fighter jets are expected to begin entering service around the 2030s, eventually replacing the F-22 Raptor as the premier air superiority fighter. How fighter jets are kept in air for longer. 6th-generation fighter jets represent a major leap forward in military aviation technology. With advanced radar systems, stealth designs, and adaptive cycle engines, the NGAD fighters are set to redefine what it means to be an undetectable and unstoppable force in the skies. This new era of air dominance promises to be a game-changer for the U.S. Air Force and its mission capabilities. Now we know that fighter jets are essential in modern warfare for achieving air superiority. One ability of these jets is interdiction missions, which involve taking on enemy targets deep behind enemy lines to disrupt their operations and weaken their combat abilities. By striking critical areas, these missions aim to throw the enemy off balance, making it tougher for them to function effectively on the battlefield. Fighter jets excel in interdiction missions due to their speed and altitude capabilities, which enable them to gather crucial intelligence like never before. They conduct aerial surveillance, closely monitor enemy activities, and act as the eyes in the sky, keeping us informed and identifying potential threats. In dogfights, these fighter jets also showcase their exceptional maneuverability and speed. Pilots skillfully navigate their aircraft, executing daring aerial maneuvers to outmaneuver and neutralize enemy aircraft. This combination of technology and piloting expertise helps maintain air superiority. Some aircraft even have the ability to connect with tanker planes mid-air, which extends their operational range. This refueling allows them to embark on longer missions and reach areas that were previously out of their strategic reach, enhancing their flexibility and effectiveness in different scenarios. The process involves a tanker aircraft transferring fuel to a receiver aircraft in flight. While the concept might seem straightforward, the actual operation is complex and requires precision to avoid collisions and other dangers. There are 2 main methods of achieving this: the flying boom method and the probe and drogue method. Each has its own advantages and is used by different branches of the military. The flying boom method is mainly used by the U.S. Air Force and involves a tanker aircraft with a rigid, telescopic tube known as the boom. At the end of the boom is a fuel nozzle, which the operator uses to connect with the receiver aircraft. This process requires precision, as the receiver aircraft must approach and align with the tanker in three-dimensional space while maintaining a consistent speed. The boom operator, often seated at the rear of the tanker, controls the boom with a joystick. Although challenging, this method allows for high fuel transfer rates, which is useful for refueling larger aircraft. On the other hand, the probe and drogue method is favored by the U.S. Navy due to its simplicity and the ability to refuel multiple aircraft at once. This method is also used by NATO allies. The tanker deploys a flexible hose with a drogue at the end, which acts as a funnel for the probe on the receiver aircraft. The receiver pilot carefully inserts the probe into the drogue, establishing a connection and allowing the fuel transfer to begin. The simplicity of the probe and drogue method means it can be used on various types of aircraft, including smaller fighters that can carry buddy pods to serve as temporary tankers for other aircraft. This flexibility extends the operational range of aircraft and supports missions over long distances. For fast-flying jets like the McDonnell Douglas F-15 and the F-22, fuel consumption can be incredibly high, especially when flying at full speed with afterburners engaged. These jets can burn through their entire fuel supply in just a few minutes. Aerial refueling allows them to cover greater distances and maintain high speeds when necessary. An example of how crucial aerial refueling comes from the U.S. Air Force's B-2 bomber fleet, which flew over 14,000 miles round trip from Missouri to Afghanistan. They refueled several times during the journey, with the help of 15 tankers from multiple bases across different continents. This operation took over 44 hours of flight time, demonstrating how aerial refueling can make even the longest missions possible. Progress made regarding aerial refueling. One of the biggest issues in aerial refueling operations is the black and white display of the current remote vision system, RVS, used. Boeing is addressing this issue by developing RVS 2.0. This upgraded system will feature ultra-high-definition cameras and 4K color screens connected via fiber optic cables, aiming to reduce latency and provide a more comprehensive visual experience. The transition from black and white to color displays seems like an obvious improvement, prompting questions about why it wasn't implemented earlier. In the interim, operators must make do with software Fix 1.5, a temporary solution until RVS 2.0 arrives. However, many boom operators find the current system challenging to use, particularly due to the lack of depth perception. RVS 2.0 aims to address this issue by incorporating a laser rangefinder to accurately measure distances, providing operators with crucial spatial awareness. Another frustration for boom operators is the absence of the boom tip in the camera feed, making it difficult to gauge positioning accurately. This shortfall forces operators to rely on shadows or, in the absence of sunlight, their intuition. Despite these challenges, operators note that the current RVS performs better at night due to reduced glare. Boeing's investment in developing RVS 2.0 is essential, considering the substantial losses incurred by one of the aerial refueling tankers program, totaling $5.4 billion to date. Originally envisioned as a next-generation aerial tanker offering advanced mission planning and data-sharing capabilities, the KC-46 has faced delays and operational setbacks. This begs the question of why traditional windows were abandoned in favor of a remote vision system. The answer lies in the long-term goal of transitioning to a fully automated refueling system, eliminating the need for a human operator altogether. Boeing has already developed the MQ-25 refueling drone capable of autonomous refueling, signaling the feasibility of such a system. With advancements in autonomy algorithms, the Air Force aims to install these technologies on KC-46 tankers, paving the way for fully automated aerial refueling operations. The Automated Aerial Refueling Program, initiated in 2004, has made significant strides toward this goal, with successful tests conducted by DARPA and NASA. As the Air Force moves forward with plans to integrate autonomy algorithms into KC-46 tankers, the future of aerial refueling appears increasingly automated and unmanned. How pilots are trained to fly fighter jets. It's no longer news that with all the technicalities discussed, a pilot, either for a fighter jet or a tanker, requires exceptional skills, extensive training, and a deep understanding of advanced aviation systems. Pilots go through rigorous training, from flight simulations to classroom instruction, and they gain hands-on experience in real aircraft. This training prepares them for the high-stakes challenges they face in the skies. Becoming a fighter pilot involves a lengthy process that demands rigorous training. It typically starts with a 4-year stint at the academy, followed by pilot training lasting just over a year. If fortunate, candidates proceed to what's known as Introduction to Fighter Fundamentals, a 2-month course in San Antonio. From there, they undergo B-course training, lasting anywhere from 7 to 9 months before joining their first operational squadron. As evident, this journey entails extensive preparation and education. Flight simulators serve as indispensable tools in pilot training, offering significant cost savings for the U.S. Air Force while ensuring safety, particularly for high-risk maneuvers. The F-35 Lightning II cockpit demonstrator, for instance, provides basic familiarization with the aircraft, while advanced simulators like the F-35 Full Mission Simulator allow pilots to complete nearly half of their initial training virtually, covering various missions. Despite the advanced technology of fighter jets, a pilot's proficiency in air combat maneuvering remains crucial in gaining the upper hand in a dogfight. Understanding one's aircraft is paramount, encompassing characteristics like turn rate, climb rate, cornering abilities, and thrust-to-weight ratio. Equally vital is knowledge of the adversary, often gained through dissimilar air combat training involving different generations of fighter jets. Training for high-performance combat involves enduring strenuous mechanical loading, which can lead to neck pain and injuries. Pilots must maintain core strength and flexibility to cope with these demands. Handling G-forces is another critical aspect, as extreme maneuvers can subject pilots to forces of up to 9 Gs. Managing blood flow to prevent loss of consciousness is essential during such maneuvers, with pilots trained to recognize signs of vision loss, indicating insufficient blood supply to the brain. To prepare pilots for the demanding situations they may encounter in the skies, various training methods and devices are employed, providing them with hands-on experience and invaluable skills. One such device is the human-rated centrifuge, a chamber where the pilot is placed and connected to a rotating arm, inducing G-loads due to centrifugal force. Personnel in the control center monitor the pilot's physiological responses and maintain communication during the test. Even experienced pilots struggle with spatial disorientation, which can be addressed through training devices like the Kraken. Located in Dayton, Ohio, the Kraken offers 6 degrees of freedom to simulate real-world flight scenarios, helping pilots overcome illusions and evaluate their responses in a safe environment. Another essential training tool is the altitude chamber, where pilots experience high-altitude conditions and oxygen deprivation to recognize the symptoms of hypoxia. This experience proves crucial in handling cabin pressure loss scenarios during actual flights. In the event of an emergency, such as an aircraft malfunction, the last resort for a pilot is to eject. However, ejecting from a fighter jet subjects the pilot's body to significant mechanical loading, necessitating proper training to avoid lethal injuries. Training devices like the lateral drift trainer help pilots master parachuting skills, ensuring a safe descent and landing in emergency situations. Survival training also covers scenarios where pilots may land in water bodies after ejecting. Pilots undergo exercises like being pulled by jet skis to simulate the dragging effect of open parachutes, preparing them for various water survival scenarios. By completing comprehensive training exercises, from handling G-loads to surviving extreme conditions, student pilots gain the skills and experience needed to become capable guardians of the skies. These training methods ensure that pilots are well prepared to handle any challenges they may face during their missions, ultimately enhancing aviation safety and readiness. Remarkable fighter jet abilities expected from the NGAD. With the evolution of fighter jets, we can conclude they are incredible feats of technology, pushing the limits of what's possible in the skies. But even with all their advanced features, these machines rely on highly trained pilots to achieve their full potential. These aviators are known for their exceptional situational awareness, quick decision-making skills, and ability to stay calm under pressure. The pilot-aircraft interface is crucial in ensuring smooth and efficient operations. Intuitive controls and ergonomics play a key role in making this possible. Pilot feedback and collaboration with aircraft manufacturers also contribute to the development of more efficient and user-friendly aircraft, which in turn enhances the overall effectiveness of fighter jet operations. Looking ahead, the future of fighter jets holds some exciting possibilities. With the most advanced jet recently revealed by the US, the NGAD, there's a lot to expect. Hypersonic speed is one area generating a lot of buzz. Hypersonic refers to speeds faster than Mach 5, which is 5 times the speed of sound. This incredible velocity opens up a whole new realm of possibilities for faster, more efficient missions. Directed energy weapons like lasers and microwave weapons are also starting to appear in fighter jet systems. These weapons can disable or destroy enemy targets with precision, offering an advantage over traditional ammunition. Directed energy weapons reduce reliance on conventional ammunition, streamlining logistics and increasing efficiency. Autonomous capabilities are another exciting area of development. Advanced fighter jets equipped with AI and autonomous systems are making their mark. This technology enhances coordination among squadrons and helps pilots focus on mission-critical aspects. AI-powered systems ease pilots' workloads and assist with decision-making, pushing combat capabilities to new heights. Unmanned combat aerial vehicles, UCAVs, are another major advancement. These drones can carry out complex missions without putting human lives at risk, revolutionizing air warfare and expanding the role of fighter jets in the skies. Stealth technology is another area where fighter jets are pushing boundaries. Jets are becoming more elusive, with advancements in reducing radar and infrared signatures. This means increased survivability for pilots and the ability to penetrate deeper into enemy airspace. Data sharing and network-centric warfare are also shaping the future of military operations. Effective data sharing enables enhanced coordination and efficiency, leading to more impactful strategies and decision-making on the battlefield. Sustainability and energy efficiency are growing concerns. Even in the realm of fighter jets, there's a push toward exploring electric and hybrid electric engines to minimize environmental impact and reduce fuel consumption. Fighter jets embody the human spirit of innovation, bravery, and skill. The NGAD will combine many of these capabilities, making it unstoppable in the air. These incredible machines represent a relentless pursuit of dominance in the skies and the unwavering dedication of the brave pilots who operate them. Thanks for watching. See you in our next video.